Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. You can find information about online seminars and study manuals for exams PFM, IFM, and LTAM that I offer at these websites. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU actuary. Here's a problem for today for exam IFM. You own a share of a non-dividend paying stock and will hold it for a period of time. You want to set aside an amount of capital as a percentage of the initial stock price to reduce the risk of loss at the end of the holding period. You are given that the stock price follows a log-normal distribution. The annualized expected rate of return on the stock is 15%. The annualized stock volatility is 40%. The investment period is 4 years. The value at risk at the third percentile for the capital plus the ending stock value equals the initial stock price. Calculate the capital amount as a percentage of initial stock price. And here's the solution. Let us write S sub t for the stock price at time t. Then R, which is the natural logarithm of S t over S0, follows a normal distribution. That's what the stock price following a log normal distribution means. With mean equal to mu minus 1/2 sigma squared times t and variance sigma squared times t. In the problem we are given that mu is 0.15 and also that sigma is 0.4 and that t is 4. Therefore R has a normal distribution with mean 0.15 minus 1/2 times 0.4 squared times 4, and that's 0.15 minus 0.08 times 0.4, which is 0.28, and variance of 0.4 squared times 4, which is 0.64. Let us write C for the capital amount. We have, in what follows, we'll use Z for a standard normal random variable and N for its cumulative distribution function. So we are given that 0.03 is equal to the probability that C, the capital, plus S sub 4 is less than or equal to S0. That's this 0.03. But we can write that as the probability that C over S0 plus S4 over S0 is less than or equal to 1. And therefore, 0.03 is equal to the probability that S4 over S0 is less than or equal to 1 minus C over S0, so that this is the same as the probability that S4 over S0 is less than or equal to the natural logarithm of 1 minus C over S0. But S4 over S0, natural logarithm of it, has a known normal distribution for which we established its mean as 0.28 and its variance as 0.64. Therefore, ln of S4 over S0 minus 0.28 over the square root of 0.64, that is actually going to be a standard normal random variable, but if we subtract 0.28 and divide by square root of 0.64, we should do this to both sides to preserve the inequality. So this is less than or equal to the ln of 1 minus C over S0 minus 0.28 divided by the square root of 0.64. And that's equal to the probability that Z is less than or equal to ln of 1 minus C over S0 minus 0.28 over square root of 0.64. But we're looking at standard normal distribution. That means that the expression that we have there on the right-hand side, Z is less than or equal to, must be such that it's equal to the inverse image under a cumulative distribution function of standard normal of 0.03, or it's the third percentile of the standard normal distribution. We can look it up to be negative 1.88. And therefore, the natural logarithm of 1 minus C over S0 is approximately negative 1.88 times 0.8 plus 0.28, and C over S0, and the quantity we're looking for, is approximately 1 minus e to the minus 1.88 times 0.8 plus 0.28, and we just calculate that, and that's approximately 0.7059484, and that's answer C. Please remember this is copyrighted material. The problem itself belongs to the Society of Actuaries, and the solution is mine. Good luck in your studies and good luck on the test.